we can define a vector function of two variables. And this could be a vector function of x and y coordinates, but in this case we're going to consider this to be a vector function of the polar coordinates in the plane. Our vector function would be defined in terms of the two polar coordinates as an x component multiplied by the I vector, a y component multiplied by the j vector, and a z component multiplied by the k vector, where x, y, and z are all functions of our polar coordinates r and theta. Now, what is the meaning of dr, d, the partial derivative of the vector function with respect to the coordinate r? This is the rate of change of our r function with respect to r. To understand what that means, we ask, well, what does a small change in the value of little r do? This implies small changes in the x of r theta, y of r theta, and z of r theta functions. Those small changes, well, if r changes by delta r, then the change in x is approximately equal to the r derivative of x times delta r. Delta y is approximately equal to the r derivative of y times delta r. And change in z is approximately equal to the r derivative of z times delta r. Now the partial of r with respect to with respect to little r, partial of our vector function r with respect to little r is approximately equal to the change in the vector function divided by the change in little r. And that, in turn, is approximately equal to the change in x times I plus the change in y times j plus the change in z times k divided by delta r, and that's equal, because of what we've seen here, to just x sub r I plus y sub r j plus z sub r k. Now, that's no surprise. We already know how to take a derivative of a vector function with respect to a variable. But we want to think geometrically about what this is telling us. So let's try to represent this within a three-dimensional plane. And let's just say we have some value of x and some value of y, as well as a value of z. Now we can kind of project that back to the z-axis. We see that z would be this coordinate here. Now, a small change delta r implies some change in x and some change in y. It also implies a change in z, but we'll work that in a minute. So let's just say that our delta x is this, and we have a delta y that is, let's say, back in this direction. So we've got a delta y here, and those combine to give us a change in position within the plane. And we're going to call that change of position delta S, and that's going to equal the delta x I plus the delta y j, where the delta x and the delta y are the changes in x and y that result from this change in r. Now let's think about what delta z tells us. Because we have a delta x and a delta y, we also have a delta z due to the change in r. Now let's first sketch a rectangle above this point, distance z above this point, and of course the top of this rectangle is going to be parallel to our delta S vector. So we have a delta S up here in this direction, congruent with the delta S down here. Our delta Z, well, here's our original value of Z, and our delta Z is simply going to increase our Z value, so we have a delta Z here. Now that delta Z is the delta Z that results from our change delta R in the value of R. So the coordinates of this point are x, y, z, and the coordinates of this point are x plus delta x, y plus delta y, z plus delta z. Where our x, y, z point is x of some r theta, y of r theta, z of r theta. R theta being the polar coordinates. Take that back. Let's ignore that. And x plus delta x, y plus delta y, z plus delta z is approximately equal to, well, this change in x resulted from a change in r, a change only in r. So this point is x of r plus delta r theta, y of r plus delta r theta, z of r plus delta r theta. Let's close that on the right page here. Okay. Now I've got a cross out and a kind of a sloppy comma theta here, so I'm going to fix those. The vector from this point to this point would be delta xi plus delta yj plus delta zk and as a consequence of what we say here, assuming delta r is small, giving us a small delta x, delta y, and delta z, delta xi plus delta yj plus delta zk is our change in the r vector. And is